We're going to review VR headsets, the 4 that I've tried, in the order that I tried them, to discuss what is good and bad about them. I'll start with this, which is the first one I got. It's the HP Reverb G2 version 2. And you know it's the version 2 because on this part here, it's got an extra layer in there, which people say you're supposed to get rid of so that your eyes get close to the lenses, but when I tried that, it just seemed blurry, and I don't think my eyes are unusually bad or different. So this HP Reverb G2 headset I found is the best all round for everything, because it's very lightweight, it's comfortable, the sound quality is very good, the picture quality is excellent. Never seen anything as good as the picture quality you get from this. It has 2K per eye, so equivalent 4K resolution. It has the best lenses of any of the headsets that I tried. You don't get any reflections or other things in there. The picture just looks clean and nice and not screen doored, not jagged. The only problem that it has is it uses Windows Mixed Reality, so there's weird software stuff which can be a bit buggy, and the controllers that it comes with are tracked by cameras on the headset, which makes them a bit finicky at times. But the good thing is the tracking of the headset itself is excellent, very good. I found it a lot better than Lighthouse-based headsets. It always knows where it is, and the one thing it does a lot better than Lighthouse-based is up and down tracking is perfect. If you go to the clubs and you're bouncing around a lot, the world doesn't come with you with this. The world stays where it is when you move up and down. Found using Lighthouse-based headsets that the world comes with you a bit, and it's quite nauseating. Doesn't feel very good. What you can do with this is use the OpenVR Space Calibrator, and then you get one of your trackers, attach it with some blue tack maybe, and hold it on here, then select it and select the headset, do a very slow calibration, waving this around in a figure 8 pattern until it tells you not to do it anymore, and then that will map the whatever they call the 3D space that the Windows Mixed Reality uses to the 3D space that the Lighthouse system uses. And once you've done that calibration, they will stay locked together until you either redefine the boundaries of this or move your lighthouses around. So good to have them screwed onto the wall and ceiling so that doesn't happen. And then you'll find to use good controllers that work properly anywhere and don't need to be in view of the cameras on the headset. So I really liked this. I stuck some fluffy things on there so the microphones don't pick up wind noise if you're running really fast. It's lightweight, it's really good and comfortable. It's got this bit of stretch, which is really good because it means you can easily just pull it off, lift it up to find where your drink of water went to or other such thing when busy long sessions. After months of this being really good, it became unreliable for unknown reason, doing weird things like saying that it's not connected when it is, or that it's gone to sleep, or when you put it on your head the picture freezes. It seemed like it might be a cable issue, but I could never correlate that to moving the cable around. So I abandoned it because it came just too hard to get it working and it was crashing, and got an Index, since that is supposedly the go-to thing for high reliability VR-ness. But unfortunately you lose resolution and image quality and comfort. That's the Valve Index in its current heavily modified form that I've been using since the G2 became unreliable. And so a few months of using this, I tried the G2 again and it seems to work now, so whatever was wrong with it seems to have gone away. Anyway, this has been okay, but the problems with the Index is it's lower resolution per eye, so sharp corners look jagged and sparkly, and you get weird reflections in the lens, so when you're in clubs and there's bright lights shining, you get weird reflections and lens flare type things, which are not very nice. It's good, it still has the stretch, the sound quality is still good, the tracking is reasonable, and yes, what I wanted to say about the G2 is that it has a very good sweet spot. It has a medium field of view, and this fall off of the sweet spot is gradual, so you don't really tell with it, so things don't look out of focus. It just looks nice. And the index is pretty similar. It seems to have around about the same field of view, possibly slightly more than the G2, but not really that noticeable. So I've added onto this the VIVE Facial tracker, which is very good for moving your mouth. I've added into there, which I was going to add into the G2, but didn't quite get to that point until it became unreliable. The iTrack VR. Is that what it's called? Yes, iTrack VR, where you make get little cameras, make a bracket thing, and attach eye LEDs to light up your eye with infrared light, and then there's this camera to look at your eye, see what it's doing, and then there's microcontrollers there which connect to the camera and send the camera data back to the computer over USB here, one for each side. That doesn't work very well. It sort of works for a while and then drifts off. So I wasn't very happy about that. And not being very happy about the low picture quality of this, I bought a VIVE Pro 2 to try out because supposedly that's got a high resolution and a good picture. VIVE Pro 2, along with the index, is a lot heavier than the G2. This was quite disappointing because it's supposed to be a high-end headset, but I wasn't very impressed with the performance. The fit did not fit very well at all for me, so I made these extra thingies to go in there because I just got light shining in down the sides. It wouldn't fit very well and I found it uncomfortable because it was poking in my forehead, but with those spaces in, it was not so bad. But I found the picture quality of this was, for such high resolution panels, supposedly it's 5K equivalent, something like that. It's not really worth it because the lenses aren't very good, so the image you get isn't really any better than what you'd get in the index. And supposedly this is OLED, I think, but I really didn't see any advantage in that either. Didn't seem any better than the index, and the sound quality is not so good on this. So that was a little bit of a disappointment. So that I kept using the index and only used this a little bit to see what it was like and hope that it was going to be better than it turned out to be. So still in search of the perfect headset. HP Reverb G2 was great, but no eye tracking, and the iTrack VR was not as good as I thought it was going to be. So I bought an HP Reverb G2 Omnicept edition, which has eye tracking, and I thought this was going to be as good as the G2, but unfortunately it's not. They've removed some of the good things and replaced them with much worse, which was quite disappointing to discover because I had no idea. I thought it was going to be the same thing but with eye tracking added. So what they did is they've taken this very nice, comfortable headband and replaced it with this terrible one that doesn't have any stretch, and the only way you can adjust it is by this knob. And so you find whenever you grab it, it seems to push itself to the tightest position, so you can't put it on. You've got to wind it out, stick it on, and then wind it in. And then, because there's no stretch, you can't just lift it up quickly to find your drink of water. You have to unwind it again, then lift it up, then put it back down, then wind it back in. It's terrible. I don't know why they do that. The VIVE Pro 2 is like that as well. It doesn't have any stretch. So that was very disappointing. The next disappointment is this nice, quite soft stuff that's here, which touches your face. It's gone. Now they got this very hard and not very well shaped stuff, so you get light shining in again because it doesn't conform very easily. So that was quite disappointing. and it's got the heart rate sensor there, which is quite painfully digging into your forehead. Luckily, very lucky, you can pull that off the same way as you can do it on the G2, and you can grab this and stick it in there. So you can solve that problem. You've got to bring the other piece. Yeah, you can't use it without the spacer though, I found, because you see there it's got the eye tracking stuff around the lenses. So if you use it without the spacer, you end up getting your nose pinched in there. Well, I guess you've got a small nose, that'll be fine. What also is interesting is, getting sidetracked anyway, so there's connections there which go to that heart rate sensor, but there's also what could be connections there, and there are pins in there, but there's nothing else. Wow, there must be, maybe they planned for another version of this which had some other type of thing in there. I don't know, it's strange. Yeah, so you can solve that problem pretty easily just by bringing it across that. And it doesn't seem to mind that that doesn't exist anymore, so that's good. This also has a face camera, so they called it, and that magnetically detaches as well. But yeah, I'm not really sure what the point of that. It's not really a face tracking camera, it seems to just be for looking at your face, but I don't have any software that can make use of that. Luckily, there is, if you use VRCFaceTrack software, has an add-in for the Reverb G2 Omnicept to get the eye tracking working, and that seems to work quite well, so that's good. So it's achieved the purpose of getting eye tracking for VRChat, but we've got a major downgrade in usability with this poor headband, which is quite disappointing. And I'm wondering now, can we take this apart and get the headband off of it and stick it onto this one? Is that possible? There are screws holding this thing together, so I guess we should try that. We'll try it on the old one first. Now, the next step is, there's no USB port on these, the HP headsets. So in order to use the mouth tracking, or the VIVE Facial tracker, we need to add USB. Got too much stuff here now. I think that's the end of the review. Now we're just looking at what's going to happen. It's not probably a very good review. So what I've got here is, this cable here is an optical USB 3 cable. That's the normal headset cable. So it's an optical USB 3 cable which comes up to there. There's a socket, then it gets broken out, and the CC line and the power lines get cut out, and then there's a PD trigger board which asks for 20 volts, and then there's a 5 volt regulator there, so that then carries on a nice new stable 5 volts locally produced to the USB hub, and then into that plugs the VIVE Facial tracker, and then another hub which goes to the eye tracking stuff, and then into this Giggle Spark, which is a haptic feedback, so you can get head pats. So on the Reverb G2 Omnicept, we're not going to need the eye tracking stuff anymore. We still need to power this, which needs USB 3 and power for haptics. It was a bit of a mistake getting this USB 3 optical cable because it's so thick and stiff. So I found a nicer one, which is much thinner and lighter. So that's a 10 meter optical USB-C cable. They didn't have 8 meter ones in stock, so got a 10 meter one. Now let's check it. Alright, so this optical USB 3 cable, this should support power delivery, so we'll just test that. So So you got 8 volts or 9 volts, 12 volts, 15 volts, 45 watts, and 20 volts, 100 watts. So this is fully supporting USB PD 3.1. It says 3.1. It's not though, is it? It says 3.1. I don't think it is. I think it's just PD3 because it doesn't go to 28 volts. But yes, it goes 20 volts, 100 watts. So that can go into the USB-C port on my computer, which supports PD. And then what the plan is, I got another one of those hubs, like what's on the other headset. I've taken it apart, but unfortunately the cable that comes with the hub doesn't have the CC line brought out of it. So I've got another one of these USB-C to C cables. So first what I've done is got one of these USB-C adapters. Plug that on there, but I found it's quite delicate, that arrangement there. You can bend it easily. Better approach I'm going to do is get this cable. I'm going to connect that up. Work out which way round it goes. You got to be careful because this cable here only brings 2 of the high-speed pairs, so it's only got one side of the USB-C cable connected, and then this will be the same because it's just 10 gigabits, not 20. So you've got to get those around the right way so it joins the high-speed lines across, and then this one around the right way so it brings the high-speed lines across. Then we'll mark it, then we'll cut it, then we'll meter out which lines go to which colors on this. Then we'll solder this end onto the hub, so we'll end up with a hub that's got a socket coming out of it, and then that can directly plug into the extension cable. And then we'll peel out the CC line which controls the power delivery, put in a PD decoy thing and another regulator, and they can have a nice stable 5 volts on the headset. No more dodgy cables, it'll just be one connection, so that will be more reliable and take up less space. So that's the plan, that's what's going to happen. To start off with, we need to work out the directions of this stuff. To join that up to the computer, we need to use this good thing called USB tree view, and then we've got to find where the... Okay, I'm pretty sure this is the hub that we're joining onto. So let's try it. So I want this end, because those are about the same height, so it will be nice for the spacing. And let's plug this in and see what happens. Nothing. Oh, there we go. Oh yeah, so the... Oops, you can only see some of it. So that came up there for the USB 3 part, and the USB 2 is connected off of that hub there. But we wouldn't need it around the other way because we need to meter out that. Okay. Nope. Okay, we'll mark that. So now we know which way around those go. Marked. So now we can cut that, work out the pinout, and wire it up. Let's just see what happens when we connect that around the other way. Don't think it will do anything. Nope. We must have just got lucky when connecting it up. Anyway, we determined that, so that's good. Before we get on to soldering this, which might be the next day depending on how things go, well, it's probably definitely going to be the next day, so we'll come back to that. I want to take apart that headset and see if we can change the strap over, just as a distraction. Let's see. I don't know, was that review comprehensive enough at the beginning? I thought it was going to be more organized than that. So that's the cable that goes to the computer, display port and power. USB. Maybe that's dodgy, I don't know. I got this one second hand because a friend showed me VRChat after I'd said I didn't, because I commissioned the avatar for VC Face, which we're using down there. Not this one, but a different one. And they asked me if I want it for VRChat. And I said, no, I don't have that or know what it is. I thought it was just some kind of socializing thing where you talk to people, which it kind of is, but turns out it's more than that. It's a place, it's a lifestyle, a place where you can go and explore amazing worlds and go to events. So they showed it to me and I said, wow, that's great. Yes, I do want VRChat now. And I found locally a headset available. Didn't really know what to look for, but I just bought this cheap one that was listed locally secondhand, which turned out to be this, and unknowingly bought one of the best ones in existence. Let's take it apart. And then got addicted ever since. Well, I've been addicted since, because it's so good to be able to go and see friends and do things, be your ideal self, go to great events, explore amazing places. So using the VIVE Facial Tracker and the attempt at eye tracking, I found those worked really well. Well, they bring life to the character, the avatar, and without face tracking, it seems very lifeless. So that's why I'm interested in getting a reliable eye tracking working. And it looks like the Omnicept can do that. I've only tried it for one session so far, I only arrived recently. But yeah, disappointed by the headband of it. Has put me off a bit because I need it to be easy to pull on and off for getting refreshments. There's an IPD, interpupillary adjustment there, which is the distance between your eyes, which is important to see the 3D effect properly. This is not very good, is it? What did I just wreck? Something. Doesn't seem to want to come apart. There must be a proper way of doing this. Maybe the front comes off? Ah, maybe the front comes... No, there's nothing under that. Some kind of elastic Velcro thing. Maybe there's a way of getting this off without having to open the main part. Let's take that, removes the speakers. I'm just wondering if there's a screw under this Velcro part. Nope. See, that just pulls in. So the stretch is just on that. It's just an elastic thing with a Velcro bit on it that creates the stretch. So simple and effective and lightweight. Maybe it comes off when you bring it to a certain position. Because it's still got the cable for the speakers somewhere. Oh, there. Okay, got that. You can take it off without taking the headset apart. So that unclips and leaves that. But you see the wire for the speakers is there. I wonder if we can just get that off completely. They've kind of ruined this now. But without taking that off more, we can't unplug the wire. I really thought that after undoing all those screws, this would just like open up. Still seems to be attached by something. Do we need to pull those out? The bits of the side cameras? Probably. Guess we can still do it. We can swap it over from the outside if we lose the speakers, because, yeah, or desolder the wires. Now will it come out? No. So I don't use the speakers anyway. I've got the earbuds attached to the headset, as you saw, because I want better quality sound for going to the clubs. Alright, we made a mess of this, and it still isn't coming apart. And I'm wondering, do I cut the wire off? Do I just chop through that wire? Where does it go inside there? And why doesn't this piece just lift out? It seems like the whole thing wants to come out. Because when I pull on that, it's moving that camera there. There we go. Maybe it was just the, probably the IPD, probably that as well, the IPD adjustment thing, that probably needs to come off. It's going to get broken off. Yes, that had to come off. The little peak thing that is now mostly destroyed. So let's see what happens. Now I guess it's hanging by these wires. Oh look, there you go. The wires go into there. Oh, the microphones. The microphones as well need unplugging. Can't get that off because it's got tape. Oh, there you go, the microphones ripped themselves out. Alright, there you go. We've ruined this now. So that's what's inside it. It's got something that looks like a magnesium alloy plate that the cameras are mounted to. I'm guessing the LCD panels will be on those as well, or CPU or something. There's a void sticker over that screw there. That cover just got ripped up because we pulled so hard on those wires. Speakers plug in there. Little Realtek chip. That would be the sound thingy. It's got hairs inside it. So IPD thing's there. The barcode is peeling off and has hairs stuck to it. See, there's a very big ribbon there. There must be a processing board for each display, and then that's connected to the display, and then that goes to the processing board. There's one each side there, and you can see that because when moving that, the edge of the cable moves, so it must be going to that. So that there's a wire to the sensor for when you have it on, detects the infrared light being reflected back. And there's the headset cable, plugs into there. I guess there's a display port to two displays splitter type thing going on in here. Is that how they do it? Or do you think they use two? The thing is that I was quite surprised about is when you plug the VR headset into the computer, it doesn't come up as a display. Nothing shows up. It's all done through the software. So even though it's plugging into the display port, it's not a monitor. So it could just be using two of the DisplayPort lanes per eye. There's a heatsink on that chip. Can't easily see what that is. Be some kind of display data thingy. Do we take it apart more? Probably not, because even though it stopped working, it seems to work again now, so I don't really want to destroy it completely, although I think we've already done that. Yeah, so the Omnicept headset is discontinued, so it wasn't that easy to find one still in stock. There's not many around now. I don't know if the normal one's obsolete or discontinued. The non-Omnicept. Just so annoying that they had to wreck the headband of it. Why would you do that? Take something that works good and then make it worse. I suppose that's just the mantra of all companies these days, isn't it? When you look at Microsoft and Windows 11, how that's considerably worse than Windows 10. It's just what you're supposed to do now, isn't it? Let's just make everything worse. Take all the good features that it had, like taskbar, right-click menu and Explorer, the start menu, all those things that people rely on, and we'll just make them worse or remove them. A great idea. So the microphones plug into there. Yeah, so we'll take the comfort of this headset and ease of use, and then we'll make it bad. So I think to replace it, what I'll do is just desolder those wires. That will be the easiest way to not have to take the headset apart. This has amazingly good microphones. They're glued into the bottom there. I don't know if that's... You see the little chippy in there? I guess that's the microphone. And it will be a downwards firing through a hole in the board. Supposedly the... Oh, look at that. I ripped off an aerial as well. I ripped off the... So there's an aerial in there, which will be for the controllers. Yeah, so I have to put that back on. Where did that go? There. Okay. Yes, so supposedly the audio aspects of this headset are the same as on the Index. Used the same speakers, same microphones. Sensible. Well, it's really good. The microphone on this is very, very good. Alright, that's a look inside the HP Reverb G2 version 2 headset. I didn't think this would be happening, but it happened. Alright, we'll continue next time, because I need to go now, with chopping that wire and attaching the USB hub and see if we can get that working. And if we can get that working, then we'll get that mounted up on the Omnicept, and then we can have a look at the eye tracking and face tracking. About a week later now, and I finally get motivation to do some more of this project, but I didn't record it. I was supposed to be going to bed, but I worked on this from 2 AM till just after 4 AM, and I finished swapping the headbands over, and I reassembled the G2. I worked out what you have to do. It's all so easy, but it only works when you're putting it back together, not the other way. Is that this front piece comes off with lots of clips. I don't think you'll be able to get it off once it's put on because of the clips that are around there. But yeah, once you pop that off, then you can slide everything into the housing, and then you can do up those delicate small cables, the little aerial cable. Good, then I guess the last thing you can do is snap that back on, but I'll leave that off for now. So I've got the G2 strapped now on the Omnicept headset, and it ended up we had to take off these inner parts as well because they're not compatible. That one has a squared corner, whereas this one, it's round. So they weren't compatible. Yeah, it's solder the wires. So that's good. That's hopefully achieve the goal of having better comfort, and critically now there's some stretch in this so you can actually get it on and off without difficulty, which yeah, I have no idea why they didn't do that in this one. Makes it incredibly hard to use with the Omnicept. The cable with 2 USB sockets has been cut in half, and I stripped out the end, identified most of the cores. I've checked the PD ability on it, so I know now that the CC lines for PD are connected, so 20 volts, and around the other way 20 volts, so that's good, that's working. The very disappointing thing that I found is that the shield of the cable is not connected to the outer edge of the connector at either end of this cable. So I've done this dodgy thing, scraped away the insulation there pulled back the shield cords because they're not attached anywhere, so you can just pull them out, twisted them together, then cut down there, soldered a wire in, and linked it to the shield. So now the shield is connected through, though not as good as it would be if it was properly attached. But yeah, the shield on this original cable is connected, so we need to do that on this. I guess some people will argue that you're only supposed to connect shields at one end, but anyway, it's connected now. Once I take that off for final installation, I need to slide some heat shrink down there and put it over this. We'll work on that USB hub next. I need to draw out this pin out and then make a conversion thing and then solder it. In the meantime, what we were going to do was have a look at what are the ICs in this thing under the cover here. We might as well have a little look at those while we're here, because we're going to do some soldering on that delicate fine USB hub. I set up this microscope camera here, which I think we can look at, yes, which might help us take a look at the ICs on this, or not. And it needs angled light. I'll find another light. There you go. LIFMD6K. I'll just look a couple of these things up, and if they're interesting then we'll take a look at what they are. It's all pretty normal, boring stuff really. That there, well, it's not what's shown on screen, that's a microcontroller, STM32. Then we've got a big chip here, which is that which you see on the screen. USB CX3 programmable MIPI CSI2 USB 5 gigabits per second camera controller. So that will be what's turning the camera data into presumably USB data to go back to the computer. And the next one, which is that one there, that's just a USB hub. USB hub 5 gigabits per second with 4 downstream ports and various other features. And then the other chip there, that's just the audio interface. Audio codec with USB to I2S audio controller and hardware active noise cancellation. Maybe that's why the microphones are so good. And so all the actual fancy stuff doing this is probably on the other side of the board. I guess it would be that area there is where that connector comes in from the main cable, and there's a cluster of stuff around there, so I was wondering is maybe something going on the other side of the board in that area, like video processor thing. It's probably not that complicated because it's just a display, isn't it? There's not much else going on other than DisplayPort data comes in, it gets split into 2 displays, one for each eye, and that's it. That's it. So USB hub chip, that's the hub, that's the camera thing. It's got a heat-sinking doofy. I guess it's a pretty hardcore hub then. I wonder if there's unused ports on that. I guess, yeah, there's other little chips that maybe, the lattice semiconductor looking thing there. Some little thing there. There will be some IMUs or accelerometer type things somewhere as well. I wonder if maybe that ST microcontroller deals with talking to those and brings the data back by USB. Yeah, I was wondering, is there any spare USB ports that we could wire out for things like the face tracking camera? But that would be quite difficult to wire onto it. So I think we'll stick with the fiber USB cable for now. There you go, that's what's in that. I think that concludes the G2 headset teardown thing. Now we're going to deal with this stuff. So I'm going to make a chart of the pinout of this original colors and then work out what colors that's going to be on this new cable. So this turns out this cable did have all 4 pairs wired, and I worked out which 2 are the relevant ones by plugging it in around the way that the USB 2 data connects through to there, and when it's around that way then measured from the high-speed pairs which 2 pairs it was on this end of the cable, and those have been identified there, which is those 2 there. So stripped back the shield to what I think will be a reasonable amount for it. Difficult because it's just foil which just flops around. All that's left to do is work out the pinout, prepare the cables, try and strip them in and then solder them in. It's got this nice little bracket thing, so that should help get the cables lined up properly the wires lined up properly, because they can lay in that thing. Although I think it's had glue poured all over it, so it's going to depend if we can pull that out easily. So I'll work that out and then show you what happened, because it's tedious and fiddly. Okay, I made a chart there that lists for both sides, that side which has got the high speed stuff on it, what it was originally and what it's going to be when we connect this new cable, and then for the other side, but also wrote on there, next step is to take off these wires, which look like they're a bit glued, so to see what happens. We won't be able to replace this sleeve strain relief thing, I don't think, or can we? I don't know, maybe we can rip that off and slide it over the new wire. I'd left this piece of insulation hanging out so that it could get flooded with hot glue, and hopefully that would make it nice, but we'll see. I guess they prepare the wires, glue them into that frame, and then it just gets slid in and then connected. So we've got to clean now this horrible lead-free solder off and put in some nice lead solder there so it will go back nicely. Okay, so that's prepared. Maybe I can give it a bit of a poking with a knife to clear the glue out, and then we can try and lay that in. But look how nice and short these wires have been prepared, and then yeah, the mess that I made. So I'm gonna have to fiddle around with that and tidy it up. I don't know how they got the shielded part to stay wrapped around the cords so nicely. As you can see there, it just unrolls itself. I don't know if they cut it in a certain way, then glued it, or did what, I don't know. There's some progress. I've got the cable prepared and mounted into this little frame thing, and I've looked at it multiple times. I'm pretty sure it's round the right way. It's very tricky, and I did manage to pull off that little strain relief sleeve thing. I'm thinking once we get it soldered on, maybe I should put some super glue under there and push it up. Not sure. We're going to attach this. I've left the CC lines need to be long because they need to go to the PD trigger. I left this long because that needs to go to a regulator, but for now we're just going to solder that on as is to test the hub, because yeah, we need to make sure it works first before doing anything else. So in theory this just slides in and all the wires are going to be in the right place, and you just kind of push them down a bit, I guess, so they touch the pads. Yeah, they're going to have to shift over a little bit, aren't they? That red one, so they line up with the pads properly. Okay, yeah, so the tweezers, the solder doesn't really stick to those because they're cold and the type of metal. So you can push the tweezers down through the blob of solder when it's molten to free up or to break a bridging. Presumably they're attached and just break off. Who would know? Well, we could meter it out, couldn't we? And it should match. The mapping should have retained. Quite hard to see what's actually going on, isn't it? It's a problem with inspection. Everything's reflective. You see that white wire there looks like it's a bit up. How gross that looks up close. How messy it is. Anyway, they're not shorted out. Great, well let's try it then. We should just go for it, right? That's the best thing to do in this situation. The wires seem to be in the right place, so let's just plug it into the cable and see what happens. We gotta work out which way round to plug it. Probably not that way. Or that way? Does that mean it's ruined then? I guess it didn't work then. Oh, well, there you go, that was that. Is there something we forgot to do? Here's another one. This one's only got USB-A outputs, no USB-C outputs. Let's just check. Does it mean we're supposed to swap the wires over or something? Like swap the cores over? So we haven't broken the USB port. Just wondering, this cable here probably has a resistor between two of the pins which tells the computer to turn on the port, because I just realized when I plug this in there's no 5 volts coming out of this, so I think we need to put these we need to have these lines hooked up in order for the USB port to turn on. I think that's what's going on here. We can prove that because if we plug that into there, nothing happens until we connect a device, and then it starts up. Oh, I don't know why that started in 5V mode. Ah, I know why. It's because this is currently connected to a port that doesn't have PD on it. That's right. So we know this is only going to allow 5V in this form, so we should be able to just do it directly and not worry about burning out the hub. So we've got to join this back on, just linked to there. Let's see what happens. Oh, the USB 3 part didn't work. Let's try it around the other way. So it's no good. I think what the problem is that it's the transmits and receives are wired wrong. We look at the USB-C connector. It's got transmits and receives on each side, and what we've done is taken a plug that's supposed to plug into a socket and replaced it with a socket that goes into a plug, but we've pinned them by having them plugged into each other, which means that the one that's on that side has ended up on that side. So whichever, the pairs are only on one side, we don't care about the other side because it's not connected. So whatever was coming out at this edge of the connector, we've connected it to the one that comes out on the top edge of the connector. As far as I can tell, the pinout has the positives on the outer edge, the negatives on the inner edge. So what we need to do is swap that with that, which means we've got a new pin out there, and we're going to pull that stuff off and do it again. And then it might work. That's what I think's happened. That's probably why it's not doing anything, because the signal's just banging into another transmitter, so it's not going to do anything. The twist of the pairs is going to get messed up, isn't it? Because they're so... now they've got to switch sides, which they didn't really want to do. The other thing that's weird is, why are there capacitors on the transmit and the receive pairs in this device? They should only be on the transmit. Anyway, I think I've connected it up around the other way, the new way, and probably not shorted. Let's just try it out. If that doesn't work, then I guess we've got to swap the plus and the minuses around as well. But let's see what happens. Oh, look, there you go. It goes now. We come up, whoops. It came up with the hub. Well, there you go. Now we can implement the PD stuff. Maybe we should plug some actual USB 3 devices into this and see if it does actually work. Two things which in theory are USB 3, a flash drive, a memory stick. Yep, look at that, it came up as a thing. And a card reader, which is supposed to be a high performance USB 3 card reader. Yeah, that came up. And nothing came up in the USB 2 slots, because yeah, there's a card reader built into this, and yeah, the other ports, USB 2 lanes, show up there under the USB 2 section. This is a thing that I wanted to run on the VR headset USB audio device, so I don't need to run an earphone cable from the computer down the headset cable to my head. It'd be nice to just plug this into the USB and have audio straight on there, because since there's no earphone socket on the headset, and I tried when doing the updating measuring to see whether the speaker connections have a common ground, because if they did, then I could turn it into a headphone socket, but they don't. They're differential or bridged amplifier outputs, so you can't turn that into an earphone socket. And also the earphone socket on the Index headset, if you plug earphones into that, it disables the microphone as well as the speakers on the headset, which is terrible because the microphone on the headset is already really good. It's very silly. This only goes when there's headphones plugged into it. There you go. The USB 2 audio thing has shown up now. Anyway, well, that worked now, which is good. So it means we can carry on the job of getting the PD stuff sorted out, getting a local regulator for 5V onto here. Get continued, got it back in the box, put some glue around some bits. Got the 5 volt coming, well, it's now going to be 20 volts coming in the ground, and then what will be the 5 volts coming out back onto the hub. I've put some heat shrink over those unused wires so they can just sit in there. Got the lid, which I drilled a hole in for those wires to come out of. I put a black stripe on this incoming one, which is going to be 20 volts, because it's important that we identify that properly. So those can get threaded in, and put the lid back on the hub. Everything's taking way longer than I thought it would. It clips and has pegs. Okay, so that's done up now. Now, got the PD trigger and a little regulator board, and I've set that up for 5 volts. And I've got a 12 ohm resistor here just to give it a little bit of load so that we can get a realistic measurement of the voltage. 5.1. You see it's about 2.6 watts in at 20 volts in, 5.1 volts out, about 2 point something watts load. And if the load wasn't there, it's pretty much the same. The regulation is pretty good. Drops just a little bit, so I think that's acceptable. Now just connect this up to the hub, and that will need to go into a little bit of a heat shrink sleeve. And trim them a bit because the insulation recedes slightly when tinning. Now they have to solder onto a particular position on that board. Those situations where a small soldering iron becomes useful. Pretty sure those are attached now. As long as that grey one's not pushing on the connector next to it. Guess that's alright. Does that count as okay? Okay, good, that's done. So I guess we just do a smoke test now. And we've got to test it by plugging it into this cable, because this is the only one that's got PD on it at the moment. Oh no, I've connected the plus and the minus around the wrong way on that. No wonder it was twisted. Ugh. You know, I was thinking, why are the wires weirdly twisted when I'd laid them out? Well, that's why, because they were around the wrong way. I've been very good luck with getting things around the right way lately. Okay, it asks 20 volts. And hopefully it's delivering 5 volts into the thing. Yes, 5.16. Okay, so then now we test it with the computer, except I have to change where the cable's plugged into, because as we know, where it was plugged into the computer before was not a 20 volt capable connection. And I've marked these so that should be the way to plug them in. There you go, look at that, it came up. And the computer's telling me that PD stuff is happening, so that's good. Okay, let's try chaining another hub off of it just for fun. Another hub, and then we can plug a USB 3 device into it. Now, if in the future we want to have more other power supplies or voltages available, we can just get that by taking the 20 volts that comes out up to here, and then put another regulator onto a different voltage, and there you go, more power. So, yeah, I'm going to get up to 60 watts on this, because the port on the motherboard's rated at 60 watts. Great! That's good. Hopefully it works reliably. Now this needs to get mounted on the headset that's got the new headband on it, and then yeah, we can do stuff. We can try it out. The eye tracking and the mouth tracking. So we'll get all that set up and then we'll try it out. Heaps more fiddling around to do. Never ending fiddling aroundness. It's becoming a really long video. Anyway, what I need to do is transfer the stuff from the other headset, the Index, to this Omnicept, work out where to mount the hub. So that's what I've been using up till now with the bodge version of the PD 20 volts thing, local regulation, the homemade eye tracking, the mouth tracking. So we need to get that off because we need it moved. So I should make a proper bracket for the mouth tracking thing, but I haven't got around to it, and then since we're swapping headsets again, I think we'll just tape it on again. Since it's meant for the VIVE Pro or 2 or something, VIVE something or other, but even then they still just tape it on. but at least the bracket kind of clicks into place. And it's also mixed in with the LEDs for the eye tracking. Okay, see, it's got this bracket thing on it and tape there, which goes on the VIVE. And we can see there, can we see there, the eye tracking cameras. So that's a little 3D printed ring VR eye track. And it's got two IR LEDs on it, one there and there. And it just sits over the ends of the edges of the lens like that. And then that clicks in place. The other thing we need to do is get the headphones off this, because I need them on the new one, and get Giggle Spark off, because I want to try and fit both onto the new one. And now hopefully the earphones can be locally driven by that little audio device, because we don't need the eye tracking anymore, so it's not going to be interfering with the audio device. So in theory it's going to work. Now this one, Omnicept, does come with this little camera which magnetically attaches there, but I don't think it's tracking, it's just looking at your mouth for whatever reason. It attaches very, very strong, and I'm wondering, can I just destroy that little camera and reuse its housing to attach this? We'll leave it off for now, and I'll just tape that on. But we've got to work out where the cable's going to go, where the hub's going to be, somewhere around there I guess, and then put the other one of these on for head pats. Tried to, I can't remember which way around they go in the software, so if it's not really going to work, is it? Because you need to get that reconnected. I suppose that will work. To see what the size is like. See, now it's got that stuff on it, which I thought it was going to be on this side, but it's not. And I suppose it could go upside down. I'm just not sure about the cable. Put this heat shrink on there as a strain relief for the connection, so that hopefully that doesn't go bad. It's still a lot of wires. Anyway, I'll sort something out, I'll fix it up, and then we'll try it out. And that will be the end, I think. Really long video about lots of stuff. I think I've got everything rigged up now. A lot of fiddling around, but strapped that connection with the optical USB onto the hub to the side here, so it's nice and tight. Unfortunately there's a weird bend in the cable, then very high bond foam tape attached to the hub along the top there. Pretty poor, but I've just taped the mouth tracking thing onto the bottom for now. It looks like it could quite easily be mounted to that little magnetic camera mount thing. I've taped it onto there. I also made this little thing so that the IPD can still be adjusted. When I was doing the calibration for the eye tracking, it seemed to think that my IPD needed to be the minimum, which is, I've never had it sit down there before. It's always been half or a bit further than half. So I made this so I can still adjust it with that taped on there in case it causes problems. Giggle Spark attached and powered by the hub. Audio coming out of the hub, and earphones are attached there. And in a while I'll try it and let you know the results, or even see the results perhaps, and then we'll be good hopefully. After all that work, should have hopefully the ultimate VR headset experience with the best picture and best comfort, which you get from the non-Omnicept version, now moved onto the Omnicept to get us eye tracking, and then the best face or mouth tracking you can get with this VIVE Facial tracker. Let's see. Now here we are in VRChat. We can try out the eye and mouth tracking. This avatar here does not have the face tracking add-on, but I noticed that it does respond to the eye tracking, so it does have something on it. I'm not sure how that works, because it didn't seem to be like that on other avatars that don't have any face tracking on them. But you can see that blinking, partially closing, and eye position. is working. So that's quite exciting. I didn't expect it to be working on this avatar since it doesn't have any specific eye tracking stuff installed. Presumably it's using the VRChat native eye tracking, which supports eye position and eye open amount. So it can't support winking. It's just both eyes are linked. And presumably the reason why other avatars don't do that is because they've got something else in them which is overriding the incoming eye tracking data, because some of those have options in the menu to change the eye shape and position, which probably takes over from, yeah, the eye tracking data. But to do the full thing, we need to choose a different avatar. The full thing. Yeah, now we can see the mouth tracking and eye tracking, because this has a VRCFaceTrack add-on added into it. So there's full support for mouth position, tongue, which is a little bit buggy, and smiling, puffing out cheeks, moving jaw. All properly supported, and because it's independent eye openness, that wink is supported. Although very strangely you can't partially close eyes, and I have no idea why that is when it's supported with the other avatars we saw. They're just either open or closed. It seems to be very smooth, the eye movement. But there's also possibly a bug in this avatar that the auto blinking still works when the eye tracking is enabled. I'm not sure why that is. Now while we're here, we should also have a look at the haptics. So I wrote some software to receive OSC data for the contact receivers on the avatar. So head pats with 2 receivers, and then nose touching. And what that's doing is that program there up on the screen is receiving OSC data from VRChat, decoding it and working out that it's something it should pay attention to, and then it's forwarding those messages onto the Giggle Tech software, which drives the little Giggle Spark. Let's see if we can start that one as well. There we go. So that shows the messages getting sent to control the motor speed, so you can get head pats. And the other thing that's going on, might as well look at all the things while we're here, is the VRCFaceTrack application. So that thing there, it's got the 2 sensors, the Omnicept for eyes and the VIVE thing for the mouth tracking, and you can see that it uses the avatar change OSC message to get the ID, then it reads all the parameters from the ID file of that avatar, and then uses that to determine what it can do, what's supported. So in this case it's 100 and whatever that says, 106 parameters available in the avatar. Whereas if we change to the other one that we were just looking at, you can see it says there 2 parameters, but I'm not sure if that is the eye tracking, because pretty much every avatar says 2 parameters, but I don't know what they are. So the other thing that I've got, I don't know which way to look because the preview is mirrored. The other haptics thing, which I haven't implemented any hardware for, but I've got the software ready to go, is contact receivers on the chest. There's a grid of them there, and a nice cat will come and demonstrate that for us. So it's a grid of 4 by 5, I think. Very good. Hopefully that was an interesting look at different VR headsets and what's annoying or good about them, and then some modifications that I did to try and realize the best headset for visuals, comfort, lightweight, face tracking, and whatever the other things are that we did.